So we're going to have a little look at part of task 2, specifically the centre of gravity analysis for your cutlery box. And what's said in the task outline here is the case must not topple over when the lid is open at 180 degrees. So essentially what that means is when you've got your box at rest like this with no cutlery inside, that it shouldn't fall and allow this underside of the lid to touch the surface that it's sat on. So there's a couple of ways that you can go about this, and I'll show you both options. The first thing you have to do is obviously give the box a density, and you would do that by assigning a material to the box. So you right click on the part here and go down to material. Unless you're using one of these materials in the quick access menu, you're going to have to go into the edit material menu, and then let's pick a reasonable plastic. So polypropylene is a nice one. Just check that there's a density in there for that. There is 993, and then we can apply that. So once you've applied a material, the geometry obviously has a density applied to it, so the software can then calculate things to do with the mass of the geometry. So one way of checking the centre of gravity, which is what we're interested in, is to open the tools menu and go to mass properties, and you'll see a lot of data that appears automatically here. It's telling you about the mass of the part, the volume of the part, surface area, but the thing that we're interested in is represented by this little coordinate system here. That's showing you the centre of the mass, so the centre of gravity, if you like. So if we look at the box side on, you can see that the centre of gravity is well within the footprint of the box. So if we rotate to the bottom of the box here, we'll just turn that off. There's the footprint. That's what's in contact with the surface that the box is sat on. So as long as the centre of gravity is within that footprint, then the box isn't going to topple over. So if we just check that again, mass properties, and you can see the centre of gravity is within the footprint there. Now that's quite a nice way to quickly check the centre of gravity, but if you're making a lot of design changes, it might be nice to have a way that's a little bit more automatic. So you could do a screenshot of this with the centre of mass data in Z, because Z is the horizontal that we're bothered about there, and that might be okay for a report, but as you're working on the box you might want to constantly check this, and a nice way to do that is if you look at the sensors folder here. If the sensors folder isn't visible, you can make that visible by going into Tools, Options, and it will be Feature Manager, and it should be in here somewhere. There you go, Sensors. So mine's set to show. There's also Hide or Automatic. If you just set that to show, and that folder should appear. And what you can do with this folder, if you right click on it, you can add a sensor, and it's a sensor that's related to the mass of the product, so that's fine. So that you would select mass properties from the top menu, and then it's not the actual mass, it's the centre of mass or centre of gravity in Z that we're interested in, so Z being this axis here, and then it's asking you to select a solid body, so we'll select this whole solid body. So it's given us the value at the moment. We're in the minus figures because obviously you can see Z is pointing off to the left here, so everything to the left of the coordinate system is a positive number, everything to the right of the coordinate system is a negative number. Now that doesn't really matter, but you've just got to be aware of that. So if we OK that sensor, and it appears up there in the folder with its value at the side, So obviously we've got that minus 100. What you will want to do now is you want to identify where the origin is, so where the part system coordinate system is located. Ours is located over here, which means that that's 0 on Z. So as you would expect, our centre of gravity, which was over here when we saw the icon for it, is roughly 100 millimeters away from that, and it's moved into the minus figures. So what it might be nice to do is set this sensor to alert us when the centre of gravity goes outside of the base of the part. So the base of the part highlighted in blue there. And there's a few things that we need to know before we can set that up. One is the distance from the origin to this edge. So if you click on the origin there in the feature tree and then click on that edge while holding down Control, and then you can go Tools, Measure, and you can measure the distance between the 2 points. Now it's the distance along Z that we're interested in. So that's about 115 millimeters. So what we're going to set this sensor to do is alert us when the centre of gravity goes into a minus figure which is greater than 115. So 160 minus 116, and then greater minus numbers than that. So the way that we do that is if you right click on the sensor and edit, and you can set up an alert here. So intuitively you would say is greater than, but because we're working in minus numbers, you have to flip that. It's going to be less than. So when it's less than minus 115, notify. So if we click on OK there, it's not less than 115 at the moment. It's still at minus 100, but let's force it to give us an alert. So one way that we can do this is by adding a large mass to the lid section here. So if we just sketch on the lid and just quickly sketch a rectangle there and then do an extrude from there, you can see that we've added quite a large mass to the lid there. So you would expect the box to topple over now, and if we do a quick refresh, you can see we're getting a warning up here. And even if you minimize the sensors folder, you still get the warning. So it's giving you an exclamation mark in a yellow triangle, and if you hover over it, it's telling you that the centre of mass in Z is now at minus 116, which is less than minus 115, so it's given us an alert. So you can then address the problem in your part, and that's just a nicer way of setting up that analysis, because it's automatic. You will get a little warning every time your part goes outside of the boundary that you've set. So that's pretty much everything on centre of mass, and you should be able to complete your report just using what I've shown you there.